When we observe deep space, we expect to see light from billions of burning stars, but occasionally we find vast dark zones. This maps the scale of Cloud 9. Spanning 4,900 light-years, it holds a mass of 5 billion suns. The chemical breakdown is remarkably pure, 99.87% primordial hydrogen, with only a tiny fraction of helium and trace elements. According to the established laws of physics, a hydrogen cloud of this immense density and mass will inevitably collapse under its own gravity. That immense pressure forces the gas to condense, igniting into a massive network of burning stars. Yet observational data shows a complete dead zone. There are 0 stars and 0 black holes inside Cloud 9. Astronomers have run countless analytical and numerical models, and until recently, none could explain how a structure this heavy stays completely dark. Standard models have been unable to reconcile this lack of activity with the cloud's density, suggesting that a localized factor or a missing physical variable is preventing the expected gravitational collapse. Resolving this discrepancy requires a different perspective, specifically the My Dear Universe, or MDU framework proposed by Nathaniel Faxon Cherier. It treats macro and microcosmic processes as components of a single unified system. To test this approach, an MDU simulation was built around the environment containing Cloud 9. The model positioned 20 surrounding galaxies, assigning active galactic nuclei, highly energetic galactic centers, to 20% of them. This data model maps neighboring galaxies. Vector lines represent plasma jets traveling 10 to the 4th kilometers per second, propelled by immense magnetic fields. Applying these parameters yielded a 100% validation score, matching the exact mass, size, and composition of Cloud 9. This correlation shifts the focus from the internal mechanics of the cloud to the violent, invisible engines firing from the galaxies surrounding it. The MDU framework identifies these engines as supermassive and micro black holes. Rather than being passive sinks for matter, they act as active drivers of cosmic energy. Interacting with galactic magnetic fields, these black holes create extreme charge separation. This process fires massive, continuous, violently turbulent plasma jets deep into space. These high-velocity jets cross the intergalactic medium and bombard Cloud 9. The constant, extreme physical turbulence prevents the hydrogen from ever condensing into the dense cores required for star formation. Evidence for this mechanism is found in the chemical makeup of Cloud 9, a total absence of helium-4. Helium-4 is an inevitable byproduct of stellar ignition. Its absence in a cloud of this mass validates the Cosmic Helium Evolution Theory, indicating that the conditions for star formation were never met in this region. The violent magnetic exhaust from the surrounding universe is actively and permanently suppressing the cloud's ability to ignite. The plasma jets seen around Cloud 9 are localized interactions within the broader universal electromagnetic field network. The expanding EMF network creates a widespread negative pressure. Rhythmic, expanding wave pulses physically push the cosmic structure apart. Mapped out, this negative pressure accounts for 68% of the universe's total energy density, the exact percentage attributed to dark energy. By accurately predicting the properties of Cloud 9, this simulation provides empirical support for the Nexon and cosmic dynamics theories, identifying black holes as primary drivers of cosmic expansion. A localized dead zone of hydrogen provided the necessary data to map the invisible architecture pushing the entire universe outward. Because of this constant suppression, Cloud 9 exists outside the typical evolutionary path of the cosmic web, acting as a perfectly preserved time capsule. Kept dormant by neighboring galaxies, its 5 billion solar masses remain an untouched relic of the early universe, free from stellar or black hole contamination. To study the specific mathematical proofs behind these interactions, read the foundational theorems in the book My Dear Universe. To see more of how the early cosmos was built, make sure to like and subscribe to MDU.